Yeah. So this is a gas which we also call as the system. This is the surrounding and this is the boundary. The internal energy of the gas in this case will be kinetic energy of this gas. The two ways the gas can exchange energy with the surrounding is in the form of heat if you are heating the gas, or in the form of work if you are pushing the piston, or if the gas is pushing the piston. Okay. Unlike chemistry, these are the only two forms of energy that we will consider. There won't be any chemical energy that will be involved. We had looked different types of systems. As we move ahead, I'll explain it to you. Open system, any interaction is possible. Closed system, okay, we will discuss this. Yeah, we said thermodynamic state. Since this is an ideal gas, the entire gas is completely described if you specify the pressure, volume, the temperature, the mass and the composition of the system. Composition means how many diatomic molecules, how many triatomic molecules, and what are their individual masses, along with pressure, volume, temperature. So in most situations the composition and the mass of the particle will remain constant, only the pressure, volume, temperature will change. So we will take a particular gas and make it expand, make it contract, heat it up, cool it down. These are the process we'll do. We will make sure that the gas particles do not leave the system, or gas particles do not enter the system. Now if you want to change a particular system of a gas, it can be done through various processes. A process is the change in the thermodynamic state of a gas. We have different processes. Cyclic process. Cyclic process means, let us say the gas is in this particular state. The pressure can be read on the y-axis, the volume can be read on the x-axis. Another important thing you should remember is, since this is an ideal gas, there will be another equation, PV equal to nRT, always satisfied. So if you know pressure of a gas, volume of a gas, N is gonna remain fixed, you will know the temperature of the gas as well from this formula. So the state of the gas is completely specified by just specifying pressure and volume. You don't need to specify temperature, because we can infer it from the ideal gas equation. So this particular gas is in this particular state A, we take it to B along this path, and we again bring it back to state A. This is a cyclic process. Non-cyclic process means if we just go to take it from A to B. Just note down that we can take it from A to B along different paths. These are all different processes, and we will name these processes in more detail as we move ahead in today's lecture. The process that we will consider is called a quasi-static process. All the processes that we will consider will be quasi-static in nature. Quasi-static means almost static. So the gas will undergo these process of change very slowly. If you suddenly expand a gas, or if you suddenly contract a gas, it doesn't have enough time to reach equilibrium. So all the processes we will study will be quasi-static, as you will see. We wrote down this particular idea, work and heat. We also wrote down the formula for pressure, the work done by a gas. What is the formula for work done by a gas? P dV. PdV is the formula for work done by a gas. The gas applies a force F. The work done by the gas is F into dx. Force is pressure into area. So the work done is pressure into area into dx. Area into dx is dV. So work done by a gas is PdV. And then we can do the integration of this, because the pressure here could be variable pressure. So just like we calculate work done by a variable force, this is work done by a variable pressure. And in this particular PV diagram, this is the process. The gas is taken from A to B along this path, and the work done by the gas from A to B is area under the curve, as we had it in as we had it in work energy theorem, similar to work energy theorem. Understood? PdV, this was the classic formula for work done by a gas. Then we wrote down the very important formula, first law of thermodynamics. First law of thermodynamics says that, we can remember it in this particular form, that I have a gas. This gas has internal energy. The two ways to change the internal energy of this gas is either by supplying heat to it or doing work on it. So we can say, if I supply heat to this particular gas, this is heat supplied to the gas. Plus work done on the gas. This is the change in internal energy. This is the first formula as it often appears in chemistry, that the change in internal energy is heat supplied by plus work done on the gas. In physics, often we will write down the formula in terms of work done by the gas, and work done on the gas and by the gas are related by a negative sign. Now this work done will be work done by the gas. Similarly, in certain problems you will see that we can also have heat supplied by the gas. Then in this formula we will have to give it a negative sign. Delta Q will receive a negative sign if this is heat supplied by the gas. So this is first law of thermodynamics, a very important law. Then we saw how do we calculate work done in different situations.